Hey, welcome. This video is on multiplying and dividing rational expressions. First, we'll talk about multiplying rational expressions. Step 1, completely factor both numerators and denominators of all fractions. Step 2, cancel or reduce the fractions. To cancel something in the numerator and denominator, the two factors must be exactly the same. And 3, rewrite the remaining factors as a single fraction. Okay, our first example. Go ahead and write the problem down. Okay, so we're multiplying fractions. When we multiply fractions, you can multiply straight across and then reduce, or you can reduce first and then multiply straight across. So if you look at these numbers, we can multiply 14 times 24 and get that answer, and then 18 times 35 and get that answer, but then we're going to have a huge fraction to reduce. So we're first going to try to reduce the integers. Okay. So looking at 14 and 35, we could reduce, if you could find a number that goes into 14 and 35. You could also reduce the 14 and 18 first. So there's multiple methods here. All right, I think we should reduce the 14 and 35 and maybe the 24 and 18 and then see where we are then. Okay, what number goes into 14 and 35? Right, 7. And what number goes into 18 and 24? Yeah, 6. So let's reduce that. So if we reduce the 14 and 35 by 7, 7 goes into 14 twice, and 7 goes into 35 5 times. So that's why I crossed them out. And the 18 and 24, we divided those both by 6. 6 goes into 18 3 times, and 6 goes into 24 4 times. Okay, now let's put it together as one fraction. We have a negative sign that was with the 14, so now that's a -2. But when we have a negative in a fraction, we usually put it in the middle of the fraction. All right, so let's multiply the top numbers. We have 2 times 4, which is 8. 3 times 5, which is 15. So we have an 8 on top, 15 on the bottom. And then the x's, well, we're going to combine the x's on the top, combine the y's on the top, and there's only y's on the bottom, so we're going to combine the y's on the bottom. Okay, so what we're doing is we're making it a single fraction. So what is that going to give us? 8 over 15, and then there's 3 x's, so that's x to the third, and there's 7 y's, y to the 7th, and on the bottom there's 4 y's. Okay, and the negative sign, it's just proper form to put it in the middle of the fraction. All right, next step is we're going to divide out the common factors. We're going to use the quotient rule for exponents. So the 8 and 15, that doesn't reduce. The x to the third, there's no x's on the bottom, but the y's, there's 7 on top, 4 on the bottom. So we're going to subtract the exponent and then keep the variable where it's a higher exponent. So there's our final answer. Negative 8x to the third, y to the third on the top, and 15 on the bottom. Okay, so in the steps, we talked about factoring. This one did not have any factoring because all the terms were monomials, meaning just one term. Okay, here's our next example. Notice that we do have two monomials again. The monomials are 12x to the fourth y squared and 20 x y to the fourth. But we also have a trinomial in the first fraction. The trinomial is three terms, x squared plus 3x minus 28. And in the second fraction, we have a binomial, x squared minus 49. Okay, so what our first step is to factor the trinomial and the binomial. So let's start with the trinomial. That's at the bottom left. On some of these fractions, we're going to have to factor both the top and the bottom. So some problems, you're going to have 4 factoring problems. You might want to label them. I like to label them BL for bottom left. TL would be top left. TR would be top right. And then BR would be bottom right, just so I don't get lost with where each of them will go once you factor it. All right, so let's factor the bottom left. That's x squared plus 3x minus 28. All right, so you know how to do that. You look for the factors of 28. There's 1 and 28, 2 and 14, 4 and 7. We want to find the pair that subtracts to be 3. Right, 4 and 7. Okay, so that first denominator that we're factored, the bottom left, is x plus 7 times x minus 4. We have one more to factor, right? The top right. Okay, so let's factor x squared minus 49. Again, on these examples, you should always pause the video and try to work it out on your own, and then come back when you're ready. Okay, x squared minus 49. Difference of two squares. Right, a squared minus b squared is a minus b times a plus b. So that would be x minus 7 times x plus 7. Okay, so let's replace those results into our original problem. Okay, now we can do some reducing. An x plus 7 with an on the bottom factors out with an x plus 7 on top. I should say they divide out or they cancel. And then the 12 and 20, what number goes into both 12 and 20? Right, 4. And then we can use our rules for exponents. There's 4 x's on top and 1 on the bottom. So that leaves us with 3 on top. And there's a y squared on top and a y to the fourth on the bottom. So that'll leave us with a y squared on the bottom. So the x plus 7 cancel. Divide the 12 and 20 by 4. That gives us 3 and 5. Okay, so you can either take care of the x's and y's right away or put it as a single fraction and then reduce it. Okay, so like we said, there's going to be 3 x's left on top and 2 left on the bottom. You don't have to distribute the 3x cubed and the 5y squared. The answer usually is written as a product of all the factors that are left over. Just make sure that you put the integer first, and then any variables, and then any binomials. So you wouldn't want to put that x minus 7 before the 3. That would just be weird. Okay? Oh gosh, this one has 4 factoring problems. I try to label each of them so that I don't get lost. I know where to insert the factorization of one of the problems. All right, so I'm going to use, let's see, TL, top left, BL, bottom left, TR, top right, and BR, bottom right. All right, let's start with the top left. Okay, again, you should always try to pause the video and factor each of these on your own. Okay, this one is a perfect square trinomial. You could use that method. You could also multiply the first number and the last number. Totally your choice. All right, I'm going to multiply the first number and the last number, and then look for the pair that adds to be 12. So 9 times 4 is 36. And I'm not going to list all the factors, but we want to find the pair that will add to be 12. Right, 6 and 6. And they're going to be both negative, so -6 and -6. So now separate your middle term into 2 terms using the pair that we just found. And then factor by grouping. Factor out a 3x from the first pair and a -2 from the second pair. The 2 binomials match. So it's 3x minus 2 times another 3x minus 2. Okay. You could write that as 3x minus 2 squared, but then it's kind of complicated to reduce. Well, not really. It's totally up to you. All right, let's work on the bottom left now. The order doesn't matter. If you want to do the top right first, that's fine. All right, 32. We don't have to multiply the first number by 32 because it's a 1. So we have a 32. We want to find the numbers that multiply to be 32 and subtract to be 4. Yeah, that'll be 4 and 8. The 8 will be negative and the 4 will be positive. We don't have to do the grouping because it's just an x squared. There's not a number in front of the x squared. So you can put it right in the parentheses, x plus 4 times x minus 8. All right, top right. X squared plus 4x. It's only a binomial. It's not the difference of 2 squares. We want to remember our factory methods. First step is to make sure it's in descending order. It is. Second step is to factor the GCF. What's our GCF here? What do both terms have in common? Right, an x. So if you factor out an x, then in the parentheses you're left with x plus 4. Okay, bottom right. Again, it's in descending order. What's our GCF? Yes, x squared. So it's x squared times 3x minus 2. So now replace all those results into your original problem. And now we could cancel. What can you cancel? You could cancel out a 3x minus 2. You could cancel an x plus 4. An x plus 4 on top and an x plus 4 on the bottom. And then you have an x on top and an x squared on the bottom. So there's going to be one more x on the bottom. So the 3x minus 2's cancel, the x plus 4's. And then there's one more x on the bottom, so that's why it's x times x minus 8. You don't need to put the numerator in parentheses because there's nothing being multiplied by it. Again, that x that's there on top next to the x plus 4, that cancels with one of the x's on the bottom. Okay, now we're going to talk about dividing algebraic expressions. Okay, so the procedure is, well, you've done division with fractions before, right? You might remember the phrase keep, change, flip. Keep, change, change. You keep the first fraction, you change division to multiplication, and then you flip the second fraction. And that's what these notes say right here. 1, rewrite the first fraction, that's keep. 2, write a multiplication symbol instead of the division symbol, that's change. 3, write the reciprocal of the original second fraction, that's flip or change. Keep, change, flip. And then 4, perform the multiplication that's in the previous examples. So do what we were just doing. Okay, here's our first problem. Keep, change, flip. So recopy the first fraction. Recopy. Write a multiplication symbol instead of a division symbol. Change. So just make a dot this time. Write the reciprocal of the original second fraction. Flip. And now it looks like the first example we did on this video. Okay, can we reduce anything with the integers? Let's see, we've got 7, 3, 2, 9. Nope, there's no reducing with the integers, right? Remember, we can reduce vertically or diagonally, but not horizontally. So you can't reduce that 9 and 3 because they're both on the denominator. They're both in the denominator. Okay, so let's combine it as one fraction. Multiply the 7 times 2, which is 14. The 9 times 3, which is 27. And then combine the x's and the y's on the top. Combine the x's and the y's on the bottom. It's just one method. To me, it makes it a little bit easier. Okay, so on the top we have a 14. On the bottom we have 27. There's 4 x's on the top, so we're adding the exponents. X squared and x squared is x to the 4th. And there's a y and a y squared. When it's just y, that's a 1. So 1 and 2 is 3. So on the top we have x to the 4th, y to the 3rd. On the bottom, there's 1x in the first fraction, and then 4 x's in the second fraction, so that gives you x to the 5th. And there's only a y to the 3rd from the first fraction. Okay, so now we're just going to do that one last step. The x's, there's one more x on the bottom, and then the y's actually cancel. So it's 14 over 27x. Not too bad, right? Okay, this one didn't have any factoring. What makes these problems difficult is just the amount of factoring that goes on. So we got one more example. Okay, let's do it. Rewrite the first fraction. Change to multiplication. Flip the second fraction. Keep, change, flip. Okay, so now we have 4 factoring problems. Again, the key is to keep it organized. Maybe you want to do the TL, BL, TR, BR and factor it. I'm sure you can factor all of them, so why don't you pause the video and work it out. Work out each of the 4 factoring problems. Remember that trinomial on the top of the right fraction, it's not in order. So you're going to need to put it in order and then factor out a -1 because the first term has to be positive. Okay, so pause and work it out. Okay, so I just put the results here. top left is x minus 2, x plus 1. The bottom left is x minus 2, x minus 5. And then again, I had to factor out a negative, so the top right is x plus 8, x minus 5. And the bottom right is x minus 4, x plus 1. Now we can cancel. Can we cancel anything? Yeah, the x minus 2's. So don't forget, we could reduce vertically. So the x minus 2's can cancel, and what else? Oh, the x minus 5's. Anything else? Right, the x plus 1's. A lot of things canceled. So we're only left with an x plus 8 on top, an x minus 4 on the bottom, and that minus sign, we write it in the middle of the fraction. We don't need to put parentheses around the numerator or denominator because nothing else is multiplying by either of those. Okay, that's it. It wasn't too bad. A little bit of work, but that's okay. You don't mind. All right, I'll see you here for the next video.